Hello, everyone. Welcome to the flow engineering session with LangChain. We're going to be using LangGraph, which is kind of our new composition method for some of these cyclic agents. I'm Eric. I'm a founding engineer at LangChain. I mostly work on the Python open source side of the company, and I lead everything partnerships and integrations. So I get to talk at fun events like this. As a quick announcement, if you're sitting at the edge of your row on the outside, if you can just like scooch in one or two chairs, so if people show up late, they can kind of like funnel in, that would be wonderful. But without further ado, let's dive in. So today we're going to first go through some background, some terms and context that will be helpful for the demo that we're going to go through. During background, we're going to talk a little bit about what flow engineering is, what LangChain is, if anyone isn't familiar, and some other terms. Then we're going to go into building with LangGraph. We're going to compose a kind of simpler agentic RAG solution in a Jupyter notebook and kind of click through that and inspect it using some other LangChain tools. We'll talk about what nodes and edges represent in LangGraph and how we can compose them into systems that can do work for us. And then last but not least, we'll go through kind of how you can follow along with progress on LangGraph. LangGraph is currently out in public beta, and show how you can get started and follow along as we release new features. So first off, two questions, quick hand raises for everyone. Could you raise your hand if you know what a tool calling model is? Awesome. And could you raise your hand if you know what the LangChain expression language is? Amazing. OK. So we'll kind of zoom through some of the earlier ones here, and then we'll go into some more detail on the last ones. So for those who haven't been following along, chat models are basically LLMs that instead of predicting just the text that comes next, they predict what message can kind of come next in some sort of chat history. And so this is the classic ChatGPT interface where you have kind of alternating human and AI messages. And at the end, you can get some text back, in this particular case, asking what the population of Paris is. Of some text of Paris's population is approximately 2.28 million. Tool calling models we use extremely heavily in LangChain agentic flows now, and in particular in LangGraph agents. And the idea here is they're basically the same as chat models, but in addition to passing those messages, you also pass some schemas of structured data that you want to get out from the LLM. And so in this case, we could pass it a tool such as city info that passes back the population as an integer. And in this case, instead of getting some text that could be harder to parse, we can get back a JSON blob where it says population 2.28 million as an integer, which is very useful for integrating downstream systems. One thing to note here is there is a distinction between tool calling models and JSON mode, if you're familiar with JSON mode models. In this demo, we're entirely going to be using OpenAI tool calling models. JSON mode can work for certain use cases, but it does have a harder time abiding by some like stricter schemas or more complex schemas. LangChain is the company that I work for. It was an open source project that was launched in the fall of 2022. And since then, we've kind of launched a bunch of different open source projects. It's really about composing LLM-based reasoning applications. And in particular, I'm going to draw a little bit of a distinction between LangChain and LangGraph, the open source libraries today, where LangChain is really focused on feed-forward use cases. So all the use cases you see highlighted in this nice little graphic, where you're just basically passing information forward. That's what LangChain really specializes in. And we'll talk a little more about that in the expression language. LangSmith is our kind of integrated debugging and observability platform. It has some other features such as a prompt hub, as well as some like evaluation features. We're going to be using that to inspect some of the traces from our LangGraph agent today. And this is kind of the platform that we offer. The LangChain expression language, we're going to use it a little bit within LangGraph nodes today. But it is a different composition method than LangGraph. And the idea here is it really just is an expressive language for composing retrievers, prompts, and chat models in this particular example in that feed-forward fashion in code. If any of you are big bash scripters, it's kind of a similar syntax to that. And then last but not least, we're going to be using flow engineering today, where instead of just doing feed-forward flows, we might also want to kind of loop back to previous states. So LangGraph really focuses on modeling these applications as state machines, where we're just jumping between different states. In this case, maybe a generation node that generates some text, and then a grader node which assesses whether it's accurate or not. And maybe it passes the final response back to the user or sends it back to generation in the event that it needs some additional work. And so this is kind of the rough composition of the flow that we're going to build today. And we're going to add some little flair to it as well. So next up, we're going to do some building with LangGraph. So conceptually, LangGraph development takes place in 3 different steps. The first thing that we need to do is define some sort of state that we want to operate on. So looking back at the kind of graph that we had before, we might want to pass some information between these nodes. Not all of these operate completely independently of each other. And so we're just going to define some sort of global state for our graph that gets tracked across a run. And so here we can ask questions like what variables we want to define there. And then we can actually add debugging artifacts to this as well. So if there's anything generated through any of the nodes that we'd want to inspect later, LangSmith makes it really easy to kind of inspect those if you pass that into the state. The second step is defining nodes for our graph. So in that graph I showed earlier, we had 2 nodes, generate and grade. And so this is where we really want to put our business logic. So how do we want to change that state object at each step of our graph's execution? And then last but not least, we're going to connect it up with edges. We don't necessarily want everything to be able to connect to everything. And we have both edges as well as conditional edges. If depending on the output of a node or an output of a function, we can kind of route our agent to different areas. And most of these terms will become more clear once we start building. So state, nodes, and edges are kind of the 3 main steps that we're going to go through today. So the main thing that we're going to build today is just something that does graded retrieval. So we're actually not even going to do generation to start. We'll add that at the end. And the idea behind this graph is we're going to just retrieve some documents. In this case, I have a vector store set up with some IMDb movie summaries, where we're going to retrieve ideally relevant documents to any query about movies. The second node is just going to grade each of the retrieved documents and whether they're relevant or not. When building these kinds of RAG systems, one of the biggest shortcomings that can happen is you actually retrieve too many documents that are completely irrelevant to the user's query. And when you pass them into the LLM, sometimes the LLM will answer the question as if it were relevant information. In one of the cases we're going to go through today, we might ask a question about James Bond movies, but if it retrieves a movie summary about Fast and Furious, it might answer as if that's part of the plot of a James Bond movie, in which case there would be way too many cars with way too few features. So that's what our grader step is going to do. And then we're going to have a conditional edge where we're going to see if we were able to retrieve any relevant documents. So kind of the worst case scenario for a retrieval step here is if we retrieve a bunch of documents that are completely irrelevant to James Bond movies, and then our grader node just strips all of those away, and now we're left with no documents left. And so in that case, we'll actually pass back to a rewriting node, which will rewrite our question such that we can retrieve hopefully more relevant documents to James Bond movies. And this is because rewriting questions actually can result in different things coming out of our vector DBs. But if we have documents, we'll pass those forward. Again, this is only graded retrieval, and so we are going to just return whatever documents we have at the end here, and not do any generation to start. So without further ado, we'll pop into some code. The first thing I'm going to do is I'm just going to set a little environment variable that will let us debug this in LangSmith. So that's just our Databricks AI Summit project. And part of the kind of conceptual steps before, this is a little dark, so I'll make it a little bigger. But if there's a way to up the and we'll figure it out. But the first step is defining state. And so for our graph that we were looking at before, we know that we're going to be retrieving some documents, and that's going to be based on some sort of question. So the main two things that we're going to want as part of our state are that kind of user question that we're going to take in at the beginning and some sort of list of documents. The third thing is the generation, which we're going to use in a later step once we actually turn this into a full RAG flow. So LangGraph is very expressive. You can actually define your state objects in a lot of different ways. Here we're going to use a Python type dict, which just enforces some dictionary structure on it. And that's how we're going to define our state. The next thing we're going to do is we're going to implement our retrieval node. And so this is just going to use that movie retriever that I have. This is just a LangChain runnable, which is kind of any of the individual LangChain operations that we want to do. And in this case, we're just going to invoke our retriever with that question in order to get back some documents. Pretty straightforward node. Things to note here are that we are essentially mutating state over the by returning a different state object than we got in. But this node is actually taking in the same type of object as it's retrieving, where it has these three keys: question, documents, and generation. The greater step is going to be a little bit more involved, and this is where we're going to talk a little bit more about tool calling models, where here we're actually going to leverage a tool calling model for a slightly contrived use case where we want a binary score of yes or no. This strategy actually tends to improve performance versus like prompting it to just respond with yes or no. We've noticed that kind of annotations on fields as part of the schemas that are passed into a lot of these tool calling models tend to abide by instructions like only respond with yes or no and those kinds of things with a little bit more certainty, which is kind of nice. So this is the schema that we're going to want to get back from our LLM, where our grade is just going to be a binary score of whether the document is relevant, yes or no. And then we're going to pass it through our lovely prompt, which we are going to pull from the LangChain hub, which is just one of those LangSmith features before. This is just kind of an interface for iterating on prompts and also tracking them across all of your traces. So in this case, we're prompting the LLM saying they're a grader, assessing relevance of retrieved documents, and just passing in the retrieved document as well as the user question to get that grade. Then we're going to pass that into our tool calling model. This section is the LangChain abstraction for using tool calling models for structured output, where we're going to force the LLM to respond with that kind of grade documents response. And last but not least, we're going to chain those together using the LangChain expression language, where we're just going to pass our input into to format it with that prompt, and we're going to pass it into our structured LLM. So here, we're going to define that node to essentially call that function based for each of the documents that was retrieved. So we're going to iterate through our documents. We're going to see if it was relevant or not, and if so, we're going to say, yes, we want to pass that forward as part of filtered docs, and otherwise, we're just going to ignore the document. And so down here, we're just going to pass that through. So we can run that. And then the simpler final one is kind of on the feedback loop, where in the event that we don't have any relevant documents, we actually want to rewrite that question in order to be able to retrieve something different. And so here we're just going to prompt an LLM to say, rewrite the following question in a slightly different way, but with the same meaning. And we're going to call that better question. OK, so here's kind of an interesting part about LangGraph, where we are going to use a kind of network X, if people have used that library before, interface in order to compose all those nodes and edges to match that diagram, that nice diagram that we had before. And so we're going to add our three nodes: retrieve, grade documents, and transform a query. And then we're going to set an entry point. So we want to start with the retrieval. That's how we kind of define where that starting arrow comes from. And then we're going to add some edges to kind of connect that up. So we can run that and try running it on movies that star Daniel Craig. And hopefully that'll start going. So we were able to retrieve 4 documents from our vector DB. 2 of them ended up being relevant, and we can see that in the end, we outputted 2 ones, one summary where we're talking about James Bond's loyalty, and one where M has to battle political forces. And we can see those coming back as a trace as well. And we'll see that our retrieval step, in addition to retrieving those 2 ones, so we had one about Skyfall, one about Spectre, but as mentioned before, our vector DB really likes associating Daniel Craig with Fast and Furious movies. So even though he didn't star in these, we're actually getting back some documents about the fate of the Furious and Furious 7 as well. But luckily, we have our grade document step, which even though it took in just those documents, we were able to filter out the ones that had no reference to Daniel Craig in the content, which is quite nice. So that is just our graded retrieval step. The next thing that we're gonna add is generation. So in order to make this RAG, we don't wanna just return raw documents to users. If we wanted to do that, we could just use Google. And in this case, we will want to add, oh, actually, one thing before that, let's test a step where we do have to rewrite the question. So in my vector database, I have no movies that star Taylor Swift. So if we ask it for that, we should be able to see it kind of loop infinitely. In this case, I'm using a LangGraph utility that limits the recursion. So in this case, we actually have no, we've essentially implemented an infinite loop, right? Because we're gonna keep looking in our vector database for movies that star Taylor Swift, and we're never gonna find any. We're just always gonna return some random questions. So in this case, we're setting a recursion limit of 10 to make our graph execution fail once we execute 10 nodes deep. This is a pretty important utility when you're doing these kinds of infinite cycles. So if we look at that one, we can see that it failed. And we can see that kind of our first retrieval step, we used just that raw movies that star Taylor Swift. And it was getting kind of Barbie movie, Fantastic Beasts, and some others, none of which have Taylor Swift in them. And then if we go down, we can see that we rewrote our query into which movies feature Taylor Swift in a starring role. And it still was not able to get that until ultimately our graph returned that recursion limit failure. Okay, so back to generation. So recursion limit of 10 reached without hitting a stop condition. So now we're gonna add our generate step where we're just gonna take in that same state object, except this time we have documents attached to it, and we're gonna try and populate that generation state that we had earlier. And so in this case, we're going to pass in Lance's nice RAG prompt, which we can look at quickly here. And we're gonna see that in this case, we're just gonna tell the LLM that they're an agent assistant for question answering tasks and give them context as well as the question and an answer to populate. This tends to work pretty well with a lot of different models. And we're just gonna chain that with our regular old GPT 3.5 as well as a string output parser here. And so when we actually run that chain, we're gonna pass it both the question from the state as well as the documents. And then produce our generation. And last but not least, we're gonna return our kind of complete state object at this point, which includes the generation as well. So that is our generate node. And at this point, we're gonna have to recompose our graph. So in addition to our retrieve, grade documents, and transform query nodes, we're gonna have a new node of adding generate as well. And we're actually gonna keep the same edges as before, except now instead of routing to the end in the event that we still have some documents as part of our state, we're gonna route to the generate node. And then from the generate node, we're gonna route to the end. So that's kind of our graph there. And now we can run that on movies that star Daniel Craig, and we'll be able to see that we get a kind of sane response of Daniel Craig stars in Skyfall and Spectre is James Bond. I think in the interest of time, if people don't have questions, we can go through some additional steps. But kind of, you can infinitely extend these graphs with lots of different nodes. So in this case, we are kind of terminating with that generation, but you could also see an extension where you actually grade it also on like whether there are hallucinations in there and you actually just want to regenerate your generation in the event of that. And last but not least, you might even have a checker for whether or not the original question got answered. So in that case, you could actually populate kind of an original question field as well in the event that over time the question actually deviates from what the original question is, in which case you could kind of steer the graph towards the correct answer again. And you can kind of keep expanding these as well. LangGraph also has great support for parallel execution, so you could also imagine some nodes that actually spawn off two other nodes or two other agents that kind of like continue to do work on that same state object or potentially modify their own state objects as well. We have lots and lots of different guides on how you can compose these different graphs as part of the LangGraph documentation. I'll have the link to that on the last slide. And I think I can publish resources somewhere in your app that you can click on. But yeah, we have a bunch of these RAG guides as part of that. We have some other use cases ranging from chatbots to customer support use cases to ones that actually navigate web browsers, where you can actually kind of steer the LLM to populate different rules there. So what's next for us? For you guys, would highly recommend starting with those LangGraph tutorials as well as following some of the LangGraph content that we're posting to our YouTube channel. These are similar to tutorials to what you saw today, and they go deeper into more specific use cases such as customer support. In terms of new developments, we mostly publish those on Twitter and LinkedIn, so would recommend following us there. And then in terms of what's coming soon to LangGraph, we're building a lot of infrastructure to host these kinds of long-running agents, as well as utilities for how you actually connect it to different services, as well as kind of give human feedback. For a lot of these, we didn't do it today as part of our solution, but you could imagine a lot of the actions you'd want one of these agents to take, you'd actually want a human approval step. So there's some utilities for like connecting it to Slack and those kinds of things. And of course, we're always publishing new examples. Would love to see you guys file some GitHub issues of kind of examples you'd like to see as part of that repo. And with that, we'll dive into some questions. Yeah?
How do you get the grading to work? How do you get it to be high quality without answering yes or no?
Great question. The question was, how do you get grading to work well? So in this particular case, it was simple prompt engineering, where in this case, grading document relevance tends to be a simpler task for LLMs to handle, where all we were doing was, and I can see if I can pull it up, was our retrieval grader, which is just asking the LLM, like, is this document relevant to this question? In general, the more powerful models tend to do pretty well with these kinds of prompts, along with the kind of enforced structure. But in general, it's just iteration on your graders. Yeah, so the question is about memory and how you manage that in LangGraph. So a lot of the examples that we have in our documentation use a form of state graph that we use today, which also has a message history as part of the state. And so you can imagine that, and I can see if I can pull up an example of that. You can imagine us adding to our state a simple like chat history as a list of messages, which can store kind of the memory of what has happened in the current conversation. LangGraph is actually remarkably unopinionated about how you actually store those memories. We've seen a lot of success in people storing chat histories as those lists of messages. That's where we have that like runnable with message history in LangChain as well. But depending on the use case, we've also seen people implement some like vector store retrieval-based memories and things like that. And so in general, LangGraph is really just focused on that orchestration of like attaching nodes and edges. And then all the memory features of LangChain are still usable from it, but it's not enforced in any way. You can actually use LangGraph entirely separate without using LangChain as well. Yeah.
So for teams that are potentially looking into moving to LangGraph and LangChain, how common is it to reuse existing agent executors as nodes or subgraphs part of LangGraph?
Yeah, so the question is about migrating from LangChain to LangGraph. And the first thing I would say is that actually you can use them together very well, where the main guide that you'll want is this migrating from legacy LangChain agents to LangGraph, where LangGraph actually implements the exact same kind of agent executor that some of you are used to from LangChain as kind of a starting point, and then you can make your nodes more complex. We have seen a lot of patterns where people are calling directly into agent executors from individual nodes, but in general, we've seen more success where people are actually turning those into like proper subgraphs within their graph, just so you can kind of debug the state all in one. The LangChain agent executor will still kind of show your traces operating on like no state at all.
In LangChain previously, you had access to the intermediate steps, which gave you kind of like the previous agent executor state. Is that still like possible to be accessed in LangGraph? Because I assume that you're not going to store each individual, let's say, who has put a message in the graph.
Yeah, great question. So the question was about intermediate state objects from past steps. And we actually just added a bunch of features related to rewind, where you actually, there's a concept of like time traveling between that execution and looking up prior artifacts.
Yeah, because it's just like, sometimes it's useful to see what was the tool output and then pass that to another agent or use that for debugging or whatnot. So I'm just curious about that. Yeah, thank you.
Cool. Yeah. Oh, sorry. Best practices for async? Oh, great question. Yeah, would definitely recommend building your LangGraph agents with Python async if you're familiar with it. It'll generally execute better in parallel. We have a lot of utilities that wrap non-async implementations in kind of async IO runs, but you can very quickly hit kind of, yeah, Python async is kind of a weird domain if you haven't mucked around in it before. It's kind of a wild west at the moment. But in general, the best practice is to just implement all of your functions as async definitions and go from there. Yeah. Oh.
Once you decide that there is an issue with the response, how do you correct it? Whether it's grading it for document relevancy or hallucination or whatnot, how do you fix it?
So the question was how to kind of implement the fixing nodes, I think?
If I understand correctly, you rewrite the question, right? So how do you change the question to make it better?
Yeah, great question. So here we can also just open the one for this particular example as an example of this, where I have to go look at that up. Rewriter. So this is going to be our prompt for rewriting, where in this particular case, we are really focused on rewriting for vector store retrieval. And so in this case, we're just prompting an LLM to do that. It really depends on what you're grading for, though. Yeah, it depends a lot on what you're grading for. In the hallucination case, we're actually just sending it back to the same LLM. We're actually not rewriting anything because hallucinations tend to be transient in that kind of flow. But yeah, in terms of correcting from kind of failed grading attempts, that's going to be very use case specific. And going through some of those LangGraph tutorial use case guides will kind of add some flavor to different ways people do that. Yeah, great question. So the question was about checkpointing and kind of storing past state. So LangGraph checkpoints are kind of the section of the documentation that you'll want to read through. Nuno has put a ton of thought into how you actually want to store those intermediate states and kind of fast forward and rewind through those. And it adds some really nice debugging artifacts as well for tracking that. And I think right now it's all backed by Postgres, but we're adding some additional integrations for other places you can checkpoint things. Yeah. Can the state change between the graph?
Can there be like new data that can be like included into the state as the graph changes, or is it like global context, full agent?
Oh, I think I understand the question. So the question I think is if you can kind of dynamically add fields to the state, or if you kind of need to abide by this schema forever. Yeah, great question. So the idea behind state graph is that you actually don't do that. Is that you abide by the state kind of throughout. You could imagine if you wanted to kind of store some like metadata that's tracked throughout the entire thing, you can also just like have a dictionary field that you can set keys on through that state. But in general, we like to model this kind of like state object as always persisting through an individual state graph. Timeouts and just give me whatever you have as an intermediate step. Yeah, so I think that's where you're really going to want some of the like recursion limit features that I was showing off with the Taylor Swift example, where in that particular case, you basically just want to proceed with like giving the user an answer of like, hey, I couldn't find any documents. So here, this would essentially be a combination of setting a recursion limit with some sort of fallback, or like essentially an exception catch to return that to the user. And I think we have time for like one more question. The question is, where are tools stored? Oh, great question. So in LangGraph, you actually don't explicitly define global tools for your agent, which is pretty nifty. So in this particular case, the main tool that we're calling is just the assessing the grade of whether the document was relevant, where we had that document grade document schema. And so here we're actually just using a pedantic base model as a tool that we're passing into our with structured output handler. But the idea behind LangGraph is you'd actually define the tools alongside the LLM that you're calling in a particular node. We've seen a lot of use cases where like the vast majority of nodes use like small local LLMs, but maybe it'll call out to OpenAI or Anthropic for certain use cases where you want kind of more complex structured output, or it's better at calling certain tools. So the tool logic is much more contained within the nodes in that case. We also have some pre-built utilities for kind of tool execution if you know that you kind of want to use a similar interface to the old agent executor with tools. And for that, would recommend going into kind of the pre-built utilities for that. Thanks, everyone. I'll hang out for a bit for anyone's individual questions, but have a great rest of your conference.